The nice thing about this method of integration by parts is that it does give us a really useful way of finding integrals that we weren't able to find before. One of those would be something like we had of the form natural log of something dx, right? We did not integrate natural logs. So how could we handle this kind of situation, right? What is the antiderivative when we actually have the natural log to begin with? Well, this is where using an integration by parts would be useful. And the reason why is that we would say, well, look, we could try to say, well, dv is equal to natural log of x dx, and then let u equal 1 or something like that. The trouble with that, of course, is that u equals 1 has a derivative of 0, and we don't want to get rid, we can't make a 0 in our derivative, so that's not going to work. So what we need to do right here is make the obvious choice and let u be the function natural log of 3x. That replacement right there means that we can say, well, let's let dv be replaced with dx. Now, while it would seem that this is going to complicate things a little bit, honestly, this is actually going to simplify things quite a bit, because when we take the derivative of u, we actually know how to get this, right? This is going to be 1 over x dx. See it? 1 over 3x times 3, that's 1 over x dx. And of course, v has as its antiderivative x. So, if we're using our rule, we can compare. Uh, if we say we have an integral of the natural log of 3x times dx, it's going to be u times v. Let's go with the rule right here so we see it in action, right? We've got u dv. Its integral is going to be u times v minus the integral of v du. So we take u, the natural log of 3x, times v, which is going to be x. I'm going to put that in front so I don't get mixed up with what's inside, minus the integral of v, which is x, times du, which is going to be 1 over x dx. See what? Look what's happening over here. We're going to get x times the natural log of 3x minus the antiderivative of dx, and that's just 1, right? So we're going to get x times the natural log of 3x minus x plus a constant. And there we go, right? That's one way of using this rule to help us find derivatives. And by the way, that's how we actually do go about finding the derivative of a natural log function.